Let's add Bluetooth to a 3D printer. This video comes out of necessity because we need a Bluetooth receiver for our hang printer project. But you can add Bluetooth to any ramps board and probably a lot of other 3D printer main boards out there. This is very inexpensive to do. It only requires one Bluetooth module, about 4 wires, and a couple of resistors. This is a yj-mcu Bluetooth module, but it's really close to an HC5 module. They're pretty much the same thing. Here I'm using a 1K resistor and a 680 ohm resistor to get the transmit traffic down to 3.3 volts. The wiring harness that I created is messy, but it'll do the job for now. I'll go back and make it smaller and clean it up later. Here's how the wiring harness is going to look for the HC05 sensor. On the ramp's AUX1 terminal, the top left pin is 5 volt. Connect it directly to the 5 volt pin on the HC05. The ground pin will connect to the 1K resistor and then on to the number 4 pin on AUX1. The transmit pin will connect directly to pin 8 on AUX1. Then the receive pin will connect to the other end of the 1K resistor and then to one end of the 680 ohm resistor. The other end of the 680 ohm resistor will go to the number 6 pin on AUX1. I'm using a blank Arduino Uno board to configure the sensor, but you can use pretty much any Arduino board for this. This is just for configuration purposes, so this will be a temporary setup. Connect ground pin of the sensor to the ground pin on the Arduino, the 5 volt pin to the 5 volt pin on the Arduino, the transmit pin TX to the transmit pin on the Arduino, the receive pin to the receive pin, the RX pin. For now, remove the 5 volt line. Cable your Arduino up to your PC via USB. Open your Arduino software and create a new sketch. Select the Uno board. Select the port the board is on. And upload a blank sketch. Once that's been uploaded, hold the button on the sensor and then plug in the 5 volt line. This will put the sensor into configuration mode. You can let go of the button and you'll see the light blink steadily once every 2 seconds. Now go back into the Arduino software and open up the serial monitor. Make sure the return characters are set to NL and CR, and the default baud rate will be 38400. Make sure caps lock is on and send an AT command. If it comes back OK, then you're communicating with the sensor. Enter AT plus version ? This will give you the version that's currently running on this sensor. I found it easiest just to set the sensor back to its original configuration. So enter AT plus ORGL. After setting back to the original configuration, your sensor will go back into the standard mode. So we'll need to go back into the command line mode. Remove the 5 volt line. Hold the button. Put the 5 volt line back in. Now we're back to configuration mode. Now that we're back into configuration mode, let's check the name of the sensor. AT plus name ? This is the default name for the sensor. This is how you know you're back to the original configuration. Now let's set the name of the Bluetooth module to hang so we know it's the hang printer. AT plus name equals hang. Check the name again. AT plus name ? Hang. Now let's check the baud rate. AT plus UART ? It's currently at 38400, 1 stop bit, parity set to none. Let's set it to 115200. AT plus UART equals 115200, 0, 0. That's 115200, stop bit of 1, parity none. Let's check it again. It's now set at 115200. Check the passcode of the Bluetooth module. AT plus PSWD ? The default is 1234. You can change this if you like, but I'm going to leave it at default. Now we can disconnect from our Arduino test setup. Cable up your printer to your PC via USB, and your Bluetooth sensor should start flashing. Now hook up your wiring harness to your RAM port. The power and ground wire goes here. The transmit wire from the sensor goes here, and the receive wire goes here. Now let's get back into the firmware, and we need to enable Bluetooth. In the version of Marlin that the Hang printer is using, the variable is called BT enabled. Just uncomment that. Some other versions of Marlin, it's just called Bluetooth. Also make sure your Marlin baud rate is set at the same speed we set the Bluetooth sensor at. In this case, 11.5200. Make sure your board is set to Mega, you're on the correct COM port, and then hit upload. Now that you're done uploading, remove the USB cable from your computer and turn the power to your printer on. Now we can connect up to the printer via Bluetooth. On your PC, open up your Bluetooth devices, right-click, Show Bluetooth Devices. Click Add Bluetooth Device, hit Bluetooth, and wait for it to search. You should see your new Bluetooth module in the list. Enter your PIN, 1234, and click Connect. And your Bluetooth module should show as paired in the list. Now that your printer is paired, let's open up Pronterface. If you need to know what COM port your Bluetooth printer is on, go to Control Panel, go to Hardware and Sound, Device Manager, and expand ports. Use the first COM port that says Standard Serial over Bluetooth, COM3. Make sure it says COM3, your speed is set to 11.5200, and click Connect. Your printer is now connected via Bluetooth. Do a test M114 command. This will show the printer's current location and will confirm you can communicate with the printer. And that's it. You should now be able to stream G-code directly from Pronterface over to your printer via Bluetooth. You could probably even set up a Raspberry Pi with Octoprint and use its Bluetooth interface as well. If you like this video, please give it a thumbs up or consider subscribing to my channel. If not, leave your thoughts below, and as always, thanks for watching.